Today we're going to be learning about the product, quotient, and chain rules when it comes to differentiation. So the product rule comes into play when you're differentiating a one function multiplying another function. And this can be rewritten as f of x times the derivative of g of x, and then plus g of x times the derivative of f of x. And this can also be looked at in terms of 1 and 2. So we have 1, which is f of x, and our 2 will be g of x. So it's the first one times the derivative, of the second one plus the second one times the derivative of the first one. So if you'll notice, it's kind of like a palindrome with the numbers, but the second term is always being derived. So we're going to work on an example of this. So we're going to use h of x is equal to 2x cubed plus 3x. And this is our first function. And then multiply that by x squared plus 4x. Now you could FOIL it out and work on it that way, or you can use the product rule and write that h prime of x is equal to the first one, 2x cubed plus 3x, times the derivative of the second one, which would be 2x plus 4, plus the second one, that one, x squared plus 4x, times the derivative of the first one, 6x squared plus 3. So if you'll notice, we have the palindrome effect. It's the same thing but written out. And then we can multiply these parts, these two, and these two, and add them together. And then we will get the derivative of this. So h prime of x would be equal to 4x to the fourth plus 8x cubed plus 6x squared plus 12x, which is this first section, plus 6x to the fourth plus 24x cubed plus 3x squared plus 12x, which is the second multiplication part. So the derivative of this equation then results to be 10x to the fourth plus 32x cubed plus 9x squared plus 24x. And we figured it out using the product rule. And this is a pretty simple equation, and there are some where you can't FOIL it out, or it's a lot harder to FOIL it out than to use this method, but it's a pretty handy rule. So the next one we're going to look at is the quotient rule. And the quotient rule comes into play when you're differentiating one function divided by another function. And so this can be rewritten as, we're going to take the bottom function, g of x, write it on the bottom. And then we're going to multiply that by itself. And then we're going to take g of x again and put it on the top, right there, and multiply it by the derivative of f of x. And then we're going to subtract f of x times the derivative of g of x. And if you'll notice, we have the same palindrome kind of effect as we had in the product rule, where the second one is always being derived, and the first one is normal. But you'll notice that it's g of x in front and f of x in second, and there is a subtraction sign here, so watch out for that. Whereas the product rule is an addition. And you also have this at bottom, which you cannot leave off, otherwise it will trip you up later. So we're going to use an example using h of x again. And we're going to do 2x minus 3 over 3x plus 2. And we're going to use the quotient rule. So h prime of x is equal to, we'll take the bottom equation and put it on bottom, 3x plus 2. And then I'm going to write out the other one, 3x plus 2, because we're multiplying it by itself. And then we're going to place it on top, 3x plus 2. And don't forget these parentheses. It helps you organize what goes where. And then we're going to take the derivative of the top, which would be 2 minus 0. And then we're subtracting the top function, 2x minus 3, times the derivative of the bottom function, 3 plus 0. So now we have our function, our equation laid out in these terms. And then we can solve it to get our answer. So h prime of x would be equal to 6x plus 4, which is the multiplying these. And then we're subtracting this chunk, which is 6x minus 9. And then that is all over 9x squared plus 6x plus 6x plus 4. And so h prime of x is equal to, and these two cancel out, so it's 0 minus 5 over 9x squared plus 12x plus 4. And there we go. Oh, never mind. This turns to a plus. So it's positive 13 on top. And that's our solution. So the quotient rule is a little bit more complex than the product rule is. So if you don't like that extra complexity, and if the product rule doesn't quite suit your fancy, we're going to take the same equation here, and then we're going to rewrite it. And we can rewrite this as 2x minus 3 over 1 times 1 over 3x plus 2. And then you'll notice that this looks a little bit different. And it looks like kind of like something we went over before, the product rule. So it doesn't work on everything, but sometimes it's nice to go back to the product rule because it's a lot simpler because you don't have a denominator. The next one we're going to look at is the chain rule. And the chain rule can be a little bit hard to wrap your head around, but it's used a lot and it's kind of important to know. So the chain rule happens when you have a function that's inside of another function. So f of g of x is the outside function, and then g of x is the inside function. So this can be rewritten as f prime of g of x times g prime of x. So it looks a little bit complex, but we're going to go over it. So the f function is our outside function, and our g of x is our inside function. So we're taking the derivative of the outside function while not changing our inside function. And then we're multiplying it by the derivative of our inside function. So it's a little bit easier to understand if you have kind of like an example. So we're going to do exactly that. So we have h of x again, and it is equal to the square root of x to the fourth plus 2x. And if you'll notice, we have our outside function, the square root, and our inside function, x to the fourth plus 2x. So when we take the derivative of this, we are going to take our outside function, which this is also equal to, say, it's the same thing as saying we have x to the fourth plus 2x to the 1/2. So when we take the derivative, we have our exponent 1/2 minus 1, and that's equal to negative 1/2. Which is also a bit tricky, but once you get the hang of fractions in your exponents when taking derivatives, it's a lot simpler. So when we take the derivative of this function, we can do 1/2 and then put our inside function, x to the fourth plus 2x, and we're not touching it, remember, and then we have our exponent, negative 1/2. And then, don't forget this part, we multiply it by the derivative of our inside function. So 4x to the third plus 2. And then after this, we have it all set up and we can solve it out. So h prime of x is equal to, and I'm going to move this whole section up here. So 4x to the third plus 2 over 2 times x to the fourth plus 2x to the negative 1/2. And I'm going to pull out a 2 from here. h prime x is 2x to the third plus 1 over 2 these cancel out. X to the fourth plus 2x to the negative 1/2. And then h prime of x is equal to 2x to the third plus 1 times x to the fourth plus 2x to the negative 1/2. And you can rewrite this to have this part be in the denominator or in a square root sign. But there's our answer. And we got there using the chain rule, because without the chain rule, it would be very difficult to get at this equation. And the chain rule it's used for a lot of other things as well. So similarly to this equation, we have this one, where we have our inside function right here, and then we have an exponent and a number out front. And this one will work much the same as this one because we have our exponent because we changed it up. But it can also be used for cosine of 6x, or anything, like cosine of anything more than just x. And our 6x would be our inside function, and our cosine would be our outside function. And it, again, works in much the same way. And then it can also work on things like this one, where the inside is actually the x squared up in the exponent of the 3, and the 3 is our outside function. So the chain rule can be pretty cool and very versatile, and a lot of equations will require it. So today we learned about the chain rule and the quotient rule and the product rule. And they are all very important for differentiating functions.